Hello and welcome to the Vector Code Quality Symposium. My name is Vinko Surija and I am the lead engineer for test automation at Rimac Technology, where I have been working for the last 6 years. In the next 15 minutes, we'll discuss how we have implemented requirements quality monitoring using Vector Squore. We'll begin by discussing the problem of requirements quality monitoring, explain how we solve the problem, and highlight the benefits of using Squore for it. So this will be the agenda for the presentation today. I will begin by discussing the problem of requirement quality monitoring, explain how we solve the problem using Squore, and highlight the benefits of using Squore for it. So let's start with introduction, specifically what motivates us to start using Squore to track requirements quality. So, what constitutes requirement quality in general? According to the formal description, it includes clarity and ambiguity, completeness, consistency, traceability, verifiability, visibility, prioritization. And they are usually checked through lengthy review sessions, making continuous monitoring impractical and technically challenging. Some metrics can be extracted from the requirements management tool via filters and dashboards, but these typically only provide current values without showing trends or changes. Different tools are used across various departments, and this can lead to the numerous data exports and imports, increasing the risk of data loss or mishandling. It is difficult to track requirements fulfillment across multiple levels from test cases. For example, checking requirement fulfillment at the system level from software level testing is often challenging or impossible using only requirement management tools. Next, it is hard to establish product maturity level per feature and identify gaps in the product. Quality insights are often not created frequently enough to have optimal effect on the project. So, what was the solution? Our solution was to track and monitor quantifiable requirement attributes and test coverage using Vector Squore. So how did we do this? We assigned various attributes to the requirements, for example, requirement type, verification method, status, and so on. Next, we defined a strict traceability diagram with relationship rules between requirements at different levels, such as system, hardware, and software. Test specifications are linked to the tested requirements, and test results are stored alongside the requirements within the same tool. In Squore, we have created a new analysis model that mirrors all requirement and traceability rules. And at the end, data is exported from requirements management tool into the Squore. So let's dive deeper into how we organize the requirements. We use Jama Connect, a very powerful web-based tool for requirement management. In Jama, different requirement type, for example, system requirement, technical software requirements, hardware requirements, are represented by the separate item types. This means that different item types can have different fields or rules applied to them. For example, some item types have an ASI level, while others do not. Some have implementation technology defined, while others it's not applicable. Our requirements are organized in tree-like hierarchy, as you can see on the right-hand side of the slide. Here we have stakeholder requirements, system architecture, software requirements, and so on. Each item type has defined upstream and downstream links for traceability, following traceability concept rules. So what do upstream and downstream mean? In this particular example, stakeholder is the upstream requirement of the system requirement, while the system requirement is downstream of the stakeholder requirement. Similarly, test case is downstream of system requirement, while the system requirement is upstream of the test case. Below is shown a very simplified relationship diagram for an item types in a simple project. In reality, such diagrams are much more complex. Test case specifications are also part of the requirements tree and traceability rules. And finally, test results and test logs are stored in Jama, as it also functions as a test management tool. It is not possible to directly import data from Jama into the Squore, so we have to do some pre-processing beforehand. The first step is to get data from Jama. This is done via REST API, where we take nightly copy of all project items from the specific Jama project and save it into the SQLite database. Since the source data is not suitable for direct import, we need to reshape and reformat it to make it compatible with Squore. Essentially, we need to transform unorganized structured data into the organized structured data. We pre-process and prepare the data using a combination of SQL queries and Python, making it suitable for importing into Squore. In Squore, we have written custom data provider for reading the data, since none of the default ones could ingest such data. In order to have any kind of analytics and monitoring, we first have to create requirements model and traceability rules in Squore. To achieve this, we have created a new analysis model for the requirements. The model then mirrors all requirement types and fields that describe each requirement type. It also mirrors all requirement traceability concept rules. We created the rules that identify violation of traceability concept. And at the end, we also included the metrics for both direct test coverage and coverage of all derived requirements. Direct coverage refers to the direct link between requirement and its test case. Derived coverage, on the other hand, involves test coverage for all requirements that are derived from a particular requirement. The data in Squore, referred to as artifacts, is organized in the same tree-like structure as they are in Jama, and we have one-to-one mapping from Squore to Jama and vice versa. Each artifact in Squore has a direct link to the corresponding Jama item via clickable URL. Artifacts in Squore contain the same information as the requirements and test cases in Jama. Now let's take a look how does this look like in Squore. Here we have a requirement dashboard that displays all relevant data and metrics for a single requirement. All metrics here are available at a glance. Similar metrics are also available for each folder, including top-level folder for the entire project, providing cumulative metrics for all sub-items. So, in the top row, we see an overview of artifact itself. We have the requirement ID, its applicability for analysis. For example, rejected or draft items are not subject to analysis. Its name, short description, a URL to the corresponding Jama item, item status, here you can see that it's approved, and verification method indicating whether the requirement is tested or reviewed for fulfillment. On the left-hand side, we have most important metrics at a glance. Requirement coverage with passing tests and all levels with the direct links. Here, we see that direct coverage is 100%, meaning that the linked test case is marked as passed. However, for the derived requirements, this is not 100%, indicating that some test cases are either not executed or are failing. Direct links are shown to the diagram on the right. Next, we have some information about the status and the priority of the requirement. In the collapse tabs, we have also information about the requirement activity, indicating creation and last modification date. And since Squore stores our modification date, it is indicating how volatile or unstable requirement is or a set is. Next, we have all linked test cases for all derived requirements. Essentially, links to the test cases used to calculate test coverage on all levels. Then, we have links to all derived requirements. And at the end, we have a direct link to the test cases, same one as in the diagram on the right. As I mentioned earlier, we have created rules to identify a violation of the traceability concept, and here are the findings of a particular set of requirements, but it can also be utilized on a single requirement. At the top, we have a total summary of all violations. As we can see the number of open violations, so these are the violations that are identified by the model but not yet confirmed through reviews, and the number of relaxed violations, basically those that are tolerated. We can also see the time evolution of total numbers, showing how many are new or have been fixed since the last data baseline. And below is the main part where are listed findings along with the number of its occurrences, number of close findings, and the new one since the last baseline. By pressing the triangle, the list will expand to show the specific requirement that violate each rule. So here are some examples of our rule violations. Here we have requirements that are not linked to the test case. We have the system architecture interface not linked to the architecture diagram, and so on. One of the advantages of these rules is that we can create more complex conditions for a rule that can depend both on item type and field values on both sides of the linkage. And I would say that this is one of the most helpful tools for both the requirement engineers and the quality assurance teams, as it enables near real-time checking for any violation of the traceability concept. Let's continue on. So next, interesting dashboard is one for requirement coverage via tests. So since test results are part of our quality management targets, it is important to have them available at a glance. The dashboard makes it easy to monitor and evaluate fulfillment of required quality targets. So let's focus on the right-hand side of the slide. So in this requirement folder, we can see that there are in total 13 requirements, and out of those 12 have to be tested, and all of them have tests linked to them. Out of those 12 tested requirements, 11 have passing test cases associated, while one requirement has a failing test case. On the table on the top right-hand side, we can see that 12 requirements are passing with a rate of 91.7%, and in total, 13 test cases are linked to those 12 requirements. In the middle, pie chart shows requirement coverage via tests. So here we can also see that one requirement is out of scope for testing. The bottom pie chart shows requirement test coverage with passing tests at all levels, highlighting that this set of requirements is missing passing test results for the derived requirements. On the left-hand side of the dashboard is a tab with a test cases report that shows test metrics on a direct and derived levels for this particular set of requirements. And finally, the graph in the middle represents requirement test coverage over time. Initially, during the test specification period, no new test cases were executed. Then, during the test execution period, test cases were executed and logged, showing how requirement coverage increased over time between weekly baselines. And finally, the dashboard that is most interesting to me, since I come from testing, is the test results dashboard. This dashboard can display data on either complete set of the project level or a small set of the tests. So, test result metrics are basically the best way to judge quality and maturity of the features within the product. Here on the left-hand side, we can see the total metrics for the test cases and their trend since the last baseline. On the top, there is a nice graphical representation of test verdicts and their evolution across baselines. But I would say the most useful representation is the test status metrics, where the test results are grouped according to the feature. This allows us to easily identify the quality and maturity of a given feature. Here we can see that many features are yet to be tested, so this purple color. Out of those that are tested, we can see that we have features where the majority of tests are passing, while on one feature, the percentage of failing test cases is quite high. In the inset, there is a dashboard for a single test case. Here we can see the basic information such as the date of execution, its duration, and test verdict evolution over time. So currently, we are not fully utilizing all the features available with our current data and possibilities that Squore offers. However, we have plans for the future implementations. First, we plan to introduce data from the defects Jira board into our analytics and then link them to the requirement and test cases. Next, we aim to incorporate dynamic quality targets that align with the project planned maturity levels over time during the development. And finally, we want to make our requirement model fully compliant with the automotive industry standards such as aerospace or ISO 26262. This will enable us to quickly perform pre-assessment of the project quality at any given time. So, in conclusion, let's review the pros and cons of using Squore to monitor requirements quality. So, the good things. On every data import, which is basically daily, we get a complete set of fresh data. Once set up, the data input can run as a scheduled task on a server and be completely automated. But most importantly, every requirement or test folder or even an item has its own complete metrics. It is easy for a requirement engineer or developer or test engineer to monitor all the relevant part of the requirements tree, while on the other side, the PM or QA can easily monitor the whole project. We have automatic indication of metrics progression or regression for each set of the requirements. We can also identify low-hanging fruits that are ripe for quick remedies. it is very easy to align with the quality management targets. And also the benefit is that evaluation of the project and feature maturity can be done pretty quickly. And all this together enables us an agile approach for fixing product gaps and defects. On the other side, we have also to consider the drawbacks of this approach. Most important thing is that it needs stable and mature requirement management concept. Without it, this approach cannot simply function at all. It also requires that requirements have all needed attributes stored with them in requirements management tool. It will be highly impractical to glue some external data and ensure consistency every time data is imported. I mean, it's quite obvious that requirements management tool need to have an API to get all required data, but there are some tools on the market that do not have it. Pre-processing of the data means that some level of programming is involved. Every time there is a change in a requirement item type, pre-processing script have to be adjusted. And creation of a Squore analytics model and preprocessor takes time and effort. Additionally, every change in the requirement management concept have to be propagated to the model. This brings us to the end of the presentation of requirements quality monitoring using Squore. I have shown how we have utilized Vector Squore to effectively monitor requirements quality. This approach enables quick and easy identification of requirements quality, coverage, and traceability violation. Test coverage metrics provide valuable insight into feature maturity during the development. Thank you very much for your attention, and I look forward for discussion in the Q&A session.